This lecture, and it's going to be a three-part lecture, is going to be on project management, which is a very important part of IT strategy. So let's do a quick review. We started off with the first two chapters on IT strategy and information, which belong to this strategy module. Then we did IT architecture. We talked about the payoffs, and that was chapter 4. Then we started with the governance module, and the first lecture in the governance module was on IT governance. And now the second lecture on this is going to be on managing projects. And the role for, again, and you'll see this as a repeated theme, the role for non-IT managers is to manage what and leave the IT managers to manage the how. So let's start with some jargon for this chapter. IT project failure is basically execution can be botched by failing to meet cost, schedule, quality expectations, and it can fail to deliver the business benefits. Now, promised business benefits is the focus. Sometimes an IT project will succeed on its technical criteria, but it actually does not. When it does not deliver on its business benefits, it is still a failure. So we have 3 criteria for any project: cheap, fast, and good. And you need to pick any 2. You cannot get all 3. You can have projects which are cheap and fast, cheap and good, fast and good, but you cannot, it's impossible to get all 3. The Pareto optimal rule, 80-20 rule, still applies here. 80% of business needs are met by 20% of the project features. So it is very important that we focus on 20% of these, get them right, and this is where the options thinking would be very useful. Kind of break it up into multiple steps, do the must do first, and then the other ones can be built on top of it. Causes for failure are imprecise business intent, unnecessary complexity, and then the lack of explicit trade-offs on cost, schedule, and scope. And the antidotes for failure are trying to discover latent business needs, making sure the scope is clear-cut, fixed, and you have constraints on the scope, and explicit accountability for business benefits. A lot of times the business benefits are vague, and we need to have explicit accountability for that. We're going to talk a lot about lean principles, rapid iteration, using less code, a lot of business involvement, and a lot of this lean manufacturing now is called agile in software development. Rollout strategy is essentially how a completed project is rolled out to users. Are we going to abruptly replace it, run in parallel, or do a chunk rollout? So let's start with track record of IT projects. 2 out of 3 IT projects fail. Half never deliver the intended business benefits. Larger the projects, the worse the outcomes are. It afflicts small, large, nonprofits, governments worldwide. And problems that derail IT projects are often predictable and preventable. It is very often not the technology which causes the problem, but simple issues of project management, which we have learned time and time again over centuries of actually dealing with projects. It's got nothing to do with technology. It has got to do with basic project management. So IT, we have about $4,000 billion are spent, $4 trillion are spent. And if we conservatively estimate, about 25% are wasted. That's about 700 billion. This would run MIT tuition free for more than 200 years. And that's the amount which is being wasted. A minuscule improvement in this kind of bad track record could have outsized societal payoffs. So IT project track record, as you can see here, here is a graph from 2011 to 2015. Here are the percentage of IT projects which have failed outright. Kind of consistently, about 20% of them have failed outright. And then we have maybe successful projects, about 30% here, close to 30% are successful. And then the ones which have failed to deliver the benefits. So here they might be technically successful, but they actually are project failures because it failed to deliver business benefits, and it's about 50% here. So half the projects fail to deliver business benefits. 20% fail outright, so 70% are project failures. And the consequences are getting worse, and that's because we are doing more and more larger projects which cost more. They are connecting multiple parts of a firm, and software is being baked into more products and services. We talked about the trifecta, and it is the problem with IT projects is that if you're building a large skyscraper, you would have to remove thousands of bricks to make it collapse. Whereas in a large IT system, one bad line of code can crash the entire system. So the most rigorous testing leaves half the bugs undetected. Malfunctioning products, resulting in malfunctioning product, stalled operations. There has been preventable deaths, especially now that software is being used in hospitals. It's not that programmers have become sloppier. How software is developed has failed to keep pace with its growing complexity. The solution is not better programmers, but better processes. So it's a problem where there is an inherent fragility of IT systems, and it's worsening because the bigger they get, the more bugs there are. It's just if we had a certain percentage, so for example here we talk about 100 mistakes for every 1,000 lines of code. So the more code there is, the more mistakes there are going to be. So ironically, the problems that often derail IT projects are predictable and preventable. And this is where history would be such an important part, because forgetting history condemns firms to repeat old mistakes instead of making new ones. So here are some timeless lessons from projects with massive scale, huge uncertainty, and bickering stakeholders. I mean, we have the railroads, the electric grid, interstate highway system, moon landing, Hoover Dam. There are timeless lessons for IT projects here, and all of them we can kind of learn issues of project management from these lessons we learned from building these projects. So let's take a massive project that promised to speed the global flow of goods, mark the depth of distance in global commerce, wipe out inefficiencies, make a fortune for all investors and stakeholders, right? This was supposed to be a win-win for all involved, but really what happened was there was unexpected glitches. The investors became paupers. The promised payoff was nowhere to be found. The project was eventually completed 6 years behind schedule. cost twice as much as it happened. And this project was a 101-mile long Suez Canal that started in 1854 that connected the Red Sea to the Mediterranean Sea. The idea was to give ships a shorter route, which original route from London to Bombay was 12,000 miles, and the route would have shortened by 5,000 miles. And this stretch of 101 miles was supposed to give net the Egyptian government a lot of revenue, and today there are 17,000 ships, 1,000 million tons of cargo each year. Egypt's share is $6 billion. But lessons of this project for IT projects is that obvious technical merits on paper don't get a project used. Suez Canal is now pirate-free, shorter, it's a cheaper trip. The IT projects can cost more and take far longer to be used, and don't expect it to sell itself to its intended users on its dead obvious technical merits and expect no payoffs until it's actually used. Right? Here's another failed project. This is the London electric bus. 100 years before Tesla. Was well engineered, 38-mile range. They came up with battery swaps which allowed them to keep running all day. The gas engine was not yet inevitable. Competition for this was horse-drawn buggies. The buses were 300% over budget. The battery was a 3,000 pound. 30 of the 50 buses were never completed. Cost, quality, schedule, it flunked all three. And again, the project simultaneously involved too many new unproven technologies. The Electrobus project often offers three forgotten lessons for IT projects. Simultaneously counting on too many unproven technologies is risky. Clever technology does not guarantee success. The best technology does not always win. A project must outdo its real competition. And for Electrobus, it was not the automobile, which was the competition, but the horse. And you have to integrate too many unproven technologies, and introducing it before complements make it attractive. In this case, charging stations also doomed the project. And this is very important now when as project managers and as line managers, you start hearing all these different new technologies like blockchain and machine learning. Without the socio-economic, socio-technical structure around it, a lot of these technologies are going to be doomed. Unless you build infrastructure, unless you have government, society all coming in, technology alone is not going to solve all the problems. So let's take the example of Hoover Dam. And contrast these project failures to Hoover Dam, which was a huge success. And the key to this success, the Hoover Dam was completed 2 years early, under budget. The managers created a master plan, but gave engineers discretion over their part of the job. And the lesson for IT projects is that line managers need to manage what, not the how. And again, this is, you see this theme repeating throughout my lecture, this whole class, is that the focus of where the line non-IT managers need to focus on is on the what needs to be done, and leave the IT department to focus on the how. We are going to stop this lecture right now and then move to the next part 2 of this lecture.